Hey, good morning. It is Monday, October 28th, and I'm Rob, that developer dad, and I'm building apps in C# and .NET. Last 2 weeks ago, I pivoted from building out the DM's familiar to planning the admin system that is going to help me take care of the businessy goop around actually running that thing as a product. And mid last week, I specified, or I wrote the specs for a piece of code that is actually pretty interesting, and it's the concept of a validation engine, one that's going to be portable, flexible, reusable. And so Thursday and Friday, I spent those streams working to build out the rules evaluation utility, and I'll eventually turn that into, or incorporate that rules evaluation utility into a validation engine. But I've been digging deep into some C# and .NET internals. A lot of reflection, a lot of behavior injection, flexibility, so on and so forth. And we're covering a lot of things that are really, really interesting from sort of a low-level coding point of view. Now, I kept going after my Friday session and generated a bunch of unit tests. Most of them are passing, but then I got into the collection-based rule for the contains operator. And my unit tests for that are not passing. And I realized that it's because it can't, or I found that it's the rule builder can't find a constructor that's able to accept a collection of allowed values. Now, there's a couple of things that we need to change around here. Number one, now let me share my screen. Boop. So contains is a little bit of a misleading name here. It's not the value I am testing contains this value, but rather, and we need to rename the symbol to is contained. Come on. Is contained by. There we go. And let's try and rebuild now. Rebuild, make sure that that symbol got updated throughout the code base. No tests. I don't have any Python tests, you silly goose. I don't know why it thought I was going to need Python tests. All right, and let's just go ahead and run all of these rules engine tests. And eventually I'm going to have tests for each of the primitive types that our rules will support, as well as for each type, each operator. And we can see that it's just vomiting all over these things. So we're getting a system exception. Rule definitions is not null here, whatever. And what's the error message that we're getting? What is it telling me? Rule definition not found. Oh, yeah, of course. So, what's going on down here in create rule definitions? Operator kind and operator kinds. Okay. Well, let's debug. Let's see what's going on here. Oh. I see it. Is contained by. There we go. Save. And I'm going to have to change it here as well. Is contained by. Save. And all right, now let's try debugging this now. It's going to throw a not implemented exception because when I figured out what's going on, I did some stuff in the rule factory. So fine, that threw up the way I expected it to. So where it was tripping, and let's find, here's the rule factory. Yes, I know. Stop it. Silly thing. Here's the rule factory. Send that away. So here's not implemented. But where it's tripping over things was down in around here. As a matter of fact, let's go ahead and comment this out. And I need, where are we? Come on, Rob. Collection type. I need this guy. Copy this. Bring it up here. And instead of returning build the collection rule, we'll do this. Oh, it doesn't even know the operand type yet. All right. Let's try this. Clean up the blank lines because we don't need those yet. Run down here. Get rid of that. And just uncomment that whole thing. Rule definition. I think I misnamed things over here. So let's, yeah. There we go. And we'll pop this in here. We don't need this to be null because we know it's a collection type. If we are in this method. So there's that. And so the problem that we're going to have here is we need to return a different kind of rule because it's not going to be able to find a constructor, well, that takes the subject operand and the accepts as the what's the word I'm using? Expression rule definition dot operator kind. Name. Oh, duh. Need to grab this, paste it back because I need it there too. And down in here, paste. And replace this with a variable. There we go. Okay, so as I was saying, the rule that we have now, the constructor only accepts, or the generic the generic rule, we'll go to the definition here. It accepts a type of T, which is the subject type, the class that we're running the rule against. V is the type of the class's property that the rule applies to. And then down here, wherever we assign somewhere in here we're assigning the base value. Here we are. So on a simple rule that's comparing one value to another value, hey Rev, we're okay to use just a public property of type V. But when we want to do the is contained by, we need that base value to be a collection of V rather than just straight up V. So I am going to create a second version of this class. And we're basically just going to copy this whole darn thing. Let's pop this guy out. And there's rule. New file. It's going to be a class. And it's going to be a collection rule. And let's paste. And I'm going to call it collection rule. Copy this. Paste that. Using system.reflection. Prop to test rule applies to get property. Yeah. Property type. Now down here under base value, we're just going to turn this into IEnumerable of V. Save that. And we've got some more errors up here. So base value, we need to change the type on this guy to IEnumerable of V. And IEnumerable, I believe, is the simplest form of collection that we can have. Now, I believe we can compile now. Let's just double check. So we'll rebuild. Okay, good. Now let's come back over to Rule Factory. And instead of it being a type of plain vanilla rule, we're going to return a collection rule. Now, I don't expect this to just magically fix everything. But let's build. Okay. What kind of problems have we got? TDD framework could not be found because I got rid of it. Goodbye. Save. No more problems. And let's pop this open and just rerun all of our tests right off the bat. And those are still failing. This one didn't even try to run. Let's try it. It's going to fail. There we go. Now we can figure out why it failed. So here's our rule factory. We'll leave that open. Collection rule. It's probably got problems. Rule factory. Let's pop in here. Drop a breakpoint right there. And debug. I'm expecting that it's blowing up in here somewhere. So let's step into rule definition equals rule definitions. Okay, we're going to step over this because we're good. Is contained by double property. Property type name is double. Rule name is double property is contained by. And the subject type name is sample subject. So there's our comparison constant. Let's go into build rule. So operator kind is contained by. And we'll go into build collection rule. All right, we can step and step. Subject type is sample subject. Operand type is, where's the type name? System.double is the operand type. Operand collection type should be an IEnumerable of type double, and it is. So this was all working on Friday when I was building this stuff out. So rule type is this. The rule constructor. Aha, okay, there's the bug. It's here. Go. And then we can watch it crash. Rule-based constructor not found. Okay. And we could just go here. Come back into the rule factory. And rule ctor, get constructor, new type array, string, IEnumerable of operand type. What are you complaining about? Oh, duh. I need to pass the actual type. Heads in my butt. And operand collection type. And then, of course, the type of rule expression. So let's take a look at this. Talk about what's going on in here. This is a reflection method. And I'm just going to tidy up this get constructor call a little bit so we can look at it a little more cleanly. There we go. So what this line of code is doing is it's actually getting the method from this type, because we don't know what the actual rule type is going to be yet because we've described it using strings. So what we need here is a collection rule that applies to this kind of class and this kind of property on that class. And we have no idea what those are when we're writing the code, because they're going to be brought in from some data source somewhere, and we can't store that kind of binary CLR information in databases or files or wherever. So we have to basically just call them out by name and say, get me the type that has this name, get me this other type that has that name, and then find me a type of collection rule, or actually not find me, but right now I want you to build me a brand new type that you didn't know about when you started, that is a collection rule that applies to this kind of object and this property on that object, or this kind of property on that object. And then it says, okay, you've got that type, great. Now find me the constructor that I can use to call to instantiate a new instance of that type you just figured out. So we're kind of getting into a place where the program is altering itself at runtime based on the data that's been supplied. Now, that's not nearly as scary as you think it is. It's not going to save this data out to disk and get smarter and smarter and then eventually launch the missiles and build killer robots. It's just, we're teaching it how to be flexible enough to be able to handle controlled, limited scenarios that we're not sure it needs to handle until it's time to handle them. So it's going to take in this operand collection type. Our operator kind is this. We've got our rule expression. See, now we're instantiating the variables that we're going to pass into that constructor. So I should rewrite this stuff. First, we need to use reflection to create a derived type for the rule definition we've passed in. We have a generic definition of a rule that uses a collection of values to test correctness, but we don't know until runtime what the subject of that rule will be, nor do we know which property and type of know the property and the type of that property until we're running the code. Translate the string values, names of those types into actual type instances. Use those types to build the concrete type of the class template, because that's really what a generic class is it's a template for a class that can operate upon some other class, but we don't necessarily know what that other class will be until we're running the code. Now we find the constructor for that type that we'll need to call. Now, a lot of people don't like lot of comments littered throughout the code. But when I'm doing generic work, it's not, somebody who's familiar with reflection can look at this code and get a gist of what's going on. But I really like to explain out what I'm doing in my reflection code, because I guarantee I'm going to come back to this code in 6 months and spend probably a half an hour scratching my head wondering what the heck I was doing. So I just like to have things spelled out super explicitly whenever I'm doing something that I consider to be a little more exotic, a little more low level. Second, get the actual instances of the types we need to pass into the constructor that we just created. So we resolve the name of the operator kind in the rule definition to an actual operator kind. We use that operator kind to create an instance of the executable expression that the rule is going to run. And now here, we need to, the operand collection type will not be null. So we can kind of get rid of this. And we can also do this, and this might fail. It'll certainly fail if I don't copy the code correctly. Let's just get rid of that. This probably ain't right. FAFO time. And can I clear all breakpoints? Toggle activate breakpoints. Here we go. Let's get rid of this one, that one. Keep rules engine tests and drop this one in. Here we go. Now let's go over to our test library and we'll try debugging this guy. All right, so we're here. We can step over this. Good. Now let's step in. We've got our operator kind is contained by, and let's go into build collection rule. We're getting our subject type, our operand collection type, rule type. We've got our constructor. And this, I don't expect this to work. Even though it's already an array, oh, look at that. Now, will the constructor work? Oh, son of a gun. Look at that. And let's keep stepping. Well, well, well. Now, So that worked out for us. Will it execute? Oh no. This operator does not support IEnumerable of t baseline values. Okay, so this is operator base, but do I have a call stack anywhere? Here it is. Rule expression, evaluate on double, test value, collection rule, t-test object. What kind of expression have I got? Is contained by. Okay. So I think it might have picked the wrong expression. Contains operator. Let's see if it actually goes down this path here. And we'll just let it run and finish failing. But we can get rid of that breakpoint. Here we go. And excuse me. Come back over to tests, debug it again, and see why it's not going down this particular path. So here's rule definitions. I can actually replace this. We'll run down there. Now we'll step into executes. So typed subject is that. What kind of expression have I got? I have the is contained by. Good. So let's step. Test object isn't null. The prop value is that. Let's go into evaluate. And expression.evaluate. Oh. No, wait. Base value is that. Test value is this. Good. Evaluation strategy is contained by. My set is this. Step in. All right. So this is rule expression. I thought I could do it with overloading, but evaluate operator. base. I might have to change that from a base class to an interface. We'll see. We step in here. You know what? I bet I just did the overload wrong. That was silly. That was very, very silly. So just continue. What if I move this in here? Just do that. Come back to the tests. Just try running that one. Just for laughs. Ho ho. Ho ho ho. Here we go. Run. And all of my tests are passing. And that is a thing of beauty. Absolutely beautiful. Good, good, good. So now I can handle this equals that, this is greater than, this is less than, so on and so forth, blah, 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 blah. I don't have a not equals, and I feel like I need one. And I'm going to take a 60-second, give or take 30 seconds break. And I'm going to add a not equals, and then we're going to add some tests for that, and carry on. So cool. Be right back. All right, I have returned. All right, first thing we need to do is add a new file. It's going to be a class, not equals operator. There we go. Pardon me. And it's going to inherit operator base. And we'll implement the abstract class, give it a constructor. Boop. And I need two operator kinds dot not equals, and that's not defined yet. Go to the definition of this. Not equals. Save. And because I like things tidy, pull that down, get rid of that silliness. Come up here. There we go. Register known type strategies. And I'm just going to format these out. so that it's a little bit easier to read. All right. And I'm going to do a magic trick. Please add type strategies for each of the primitive types available in .NET to test for inequality. Because that's a lot of repetitive code, and repetitive, boring code is where bugs live. Let's take a look. So we've got double, float, long, short, byte, bool, character, and string. I can accept that and save IRule. Frickin' love AI. So there's a not equals operator. And here's my rules expression. Operator base, we can get rid of that. Collection rule, we have successfully implemented that. Contains rule factory, rules engine tests. I'm going to collapse this and let's come up. I'm going to collapse. Okay, Boolean is already collapsed. And let's add a couple new facts. Fact. With subject match, expect false. Create sample. False. Subject equals, or wait, subject dot double property. We want to get the default value of type double that we're using. And I've got a private method down here in my test stuff that just creates default test values. And then I want to test fact, let it think, and when the subject does not match the rule or the base value in the rule, I expect this to return true because we are testing not equals. I believe create sample just gives me some stuff. Good. But what I'm going to do, just to make for sure, subject, get default value +1. Let's open up our test lab again, refresh. We've got a couple unrun tests. Let's just run everything. Flurp. Now, I might have gotten things backwards. If I did, I'll fix it. Argument out of range. What are you talking about? Oh. Ha! Because I didn't add the not equals to the rule expression create operator thing. That's fine. We'll fix it. I will fix. I am smart. I will make it go. And I'm going to put not equals right there. you talking about? Copy that. I obviously spelled something wrong there. Okay. Save. Rerun these. And again, I might have gotten the logic in the test code wrong, but nope, it passed. Good stuff. All right. And the TDD enthusiasts out there are cringing because your test should always fail the first time. Well, yeah, they did because I screwed something up and they caught my error. But I mean, like, the test-driven development folks would say, you should always write your tests before you write your code. Well, I wasn't sure which tests I needed yet. So, tough. All right. So, let's go into our rules engine tests. And rather than me writing all of this crap by hand, because that's crazy, it's 2024. Using the methods described in the double property rule tests region of this file, please implement the same set of tests against the float property. Analyzing the code file. I could probably just do this as a big honkin' loop test using reflection to go through the list of property types and the list of operators and all of that stuff, but no. I'm not going to mess with that. That would be absolutely goofy and an abuse of my magic reflection powers. Is it still working? It's still working. Let's see what it looks like. And these all look pretty good. Man, it's going. Working, working, working. Good grief. Less than, greater than. Is he done? Oh, look at you. Okay, so let's accept this. Yeah. And can I save as? File, save as. this goes into rules engine tests and rules engine float prop tests. Save. And I'm going to change this. Rename symbol to rules engine float prop tests. There we go. Let's crack open this, refresh our test list. I bet, is it missing a test class? Nope. Okay. Maybe I need to rebuild. Does it see this as part of the class or as part of the assembly? Maybe not. So I guess what I'll do here is just come in here. Cut that. Paste it all in here. Now, it doesn't like something. Region, float property rule. I have to end the region. There. Save. Close. Don't save. Delete. Yep. Okay. Now let's rebuild. Rediscover the tastes. We should have a whole bunch more tests in there. Oh yeah, there we go. Run them all. And we've got 30 of 30 passing. And I did grin and collapse that region. Please generate. Please insert tests for the long property using the same pattern, using the tests against the float property as a model. Okay. It's going to generate the whole thing in its own file, but I'll just pull them over. And that's going to take a minute. At risk of sounding like an old man, you kids don't know how good you have it with this generative AI coding assistant stuff. Like, my goodness. I remember having to write these tests by hand. And guess what? when we had to write them by hand, they didn't often get written. Like, why the hell would I spend 3 days typing in unit tests for all of these different properties and all of these operators when I could just, run it over and over and over again and see how it works? And that's why I always caught hell for missing edge cases when I was a BB developer. So, yeah, this is a nice, tidy luxury. All right, I'm going to accept this. And let's just drop the cursor here. Long property rule tests. Come down at the bottom. Cut. Paste. Close. Nope, don't save. Goodbye. And we'll come to the front of this line. There we go. And there we go. And we can collapse that and run them. Refresh. Run them all. I'm up to 100 tests in the span of what? 15 minutes? Oh, 44 tests in the span of 15 minutes. Not mad about that at all. Using the tests for double, float, and long, please generate the tests for the short property. Off it goes. And yeah, I've got a bunch more types to test in here. I'm probably not going to do... Well, we've already got long. I'm probably not going to do short, byte, or I'm doing short, but I'm probably not going to do byte. I'll do char, string, and int because those are common. Decimal, I probably don't have to do because I'm already testing 2 decimal types. And I should do date time. So I'm going to get... You know what, though? I feel like decimal's a bit of an odd duck for some reason. So let's not do byte. There's that. Yeah, I really feel like decimal's an odd duck, as I said. And just for laughs, in .NET, how does the decimal type differ from double and float? These are those things that you take for granted and you never dig in. Okay, decimals are about precision. Okay. Binary integer representation, which avoids rounding errors in decimal arithmetic. Doubles and floats are better for scientific and engineering calculations, as they can handle much larger and smaller numbers with a broader range of values. Okay. Just writing unit tests for a property comparer and was wondering, thinking about skipping decimal because I've already got tests for float and double. And Microsoft Copilot is scolding me. May feel like overkill. Future self will thank me for covering all the bases. And honestly, it's like a minute while I wait for GitHub Copilot to create the tests for me, rather than having to type them all out by hand. So, yeah. So here's region short property. Come down here. Cut. All right, short stuff. Paste. Back this out. And you know what? There's no need for y'all to watch me beg Copilot to do my work for me. Oh, look, we have an error. What's up in here? What are you complaining about? This can go away. Close. Don't save. Short.get default value, type of short. Short property is a short. What's this barking about? Oh. What even? I wonder if I surround this whole thing. Unboxing conversion. Okay, fine. So we'll do that. We're going to cheat. Subject dot short property. And I'm just going to go boop, boop. There we go. All right. Now, what's all this complaining about? Quick fix. Remove unnecessary cast. Quick fix. Fine. All right. So there we go. And we're set. So when we get to the smaller integral types, I'm probably going to have to watch myself here that I'm not trying to do some sort of invalid cast or what have you. So I'm going to do the rest of these offline between now and 1. And once I've got all of these tests written and they're executing, we're going to migrate all of this work into an actual repository that I can push up to GitHub and start making available to folks that might want a simple rule expression or rule execution utility. And then we're going to start extending this concept. So thanks for joining me this morning. I will see you all back here this afternoon, those of you who can make it. And until next time, happy coding. Take care, everybody.